Hello all. Good evening, one and all. So, welcome to the first live interaction problem solving session for the course Geotechnical Engineering 1. Uh, the principal instructor for this course is Professor D.N. Singh, and I am Yogendra Narayanan, and I am a PMRF research scholar. So, as a part of my uh, external TA, teaching assistantship, I am conducting this live problem solving session for this particular course of Geotechnical Engineering 1. And the usual timings for this course will be on Saturdays, 5 p.m. to 7 p.m. So, uh, to give a brief idea about what will be uh, what we will be doing in these sessions will be based on the course contents for the particular week, that is the bygone week. Uh, Based on the concepts that was taught uh, in that in the corresponding week, we will be solving some of the we will be first revisiting some of the concepts and how to use those concepts to solve the uh, e- solve the uh, solve various problems. Especially this session will focus on solving previous year's assignment questions. And furthermore, uh, to generate discussions on various uh, topics that has been covered in the particular week, if the participants would like to discuss. So, with this as pretext, let us now go into the session. So, as it is the first week session, is mostly of an introductory session in which I will be covering what has been taught. I will give a gist of what has been taught in the lectures for week 1, and based on the lectures we will be solving some of the subject uh, subjective problems. I would say subjective questions or conceptual questions based on the lectures. So, as this is a introductory session, there is relatively lesser course content that has been covered, and therefore lesser questions have been prescribed or have been included in this session. But uh, I have I have tried to enhance the uh, learning through this session by incorporating some of the additional details which I felt would be necessary in order to solve those questions for getting a uh, more getting more clarity on the topics. So with this, we will be let me share my screen. Uh, so as I said, this course is handled by Professor D.N. Singh, and I am Yogendra Narayanan from Department of Civil Engineering, and I am a second year PhD scholar, PMRF research scholar. So to start with, uh, week 1 at a glance. So we will be concentrating what has been taught and what to start with. What is uh, civil engineering, and what is to understand what is geotechnical engineering and how it branches out from civil engineering, on what aspects it concentrates, how it is unique from other branches of civil engineering. And with this pretext, we'll be going into the uh, initial uh, formations of soils, and finally the syllabus, course contents, and the uh, prescribed books. So essentially, civil engineering, if you see, it is essentially to it is a branch of engineering that is directly associated with improving the lifestyle of people. So be it infrastructure, be it uh, uh, many aided facilities, agricultural facilities, food supply, transport, uh, communication structures, uh, anything that is involved with improvement in lifestyle of people fall under civil engineering. So in that, one of the major branches is geotechnical engineering, and which essentially relates with the aspects related on ground and below the ground. So ground in the sense, the material that is present on and below the earth, which are generally termed as geomaterial. So geomaterial essentially we consider soils and rocks. So the as far as this geotechnical engineering one course is concerned, it will be most it is it covers only the aspects of soils, since rock mechanics is a relatively advanced course, and it is offered for PG and at the undergraduate level, or at this basic level. Geotechnical engineering one comprises of uh, aspects related to soils. So the statement of, for example, the statement of democracy given by Dr. Mr. Abraham Lincoln can be modified for geotechnical engineering also, which consists of on or in the soils, for the soils, and by the soils. So what does these three mean? So on or in the soils relate to the infrastructure that is constructed on, that is above the ground, or in the soils below the ground. Uh, for example, superstructure and substructure. And for the soils means, a perfect example would be retaining structures, uh, which are used to hold the uh, soils in a slope. For example, if you would have seen in the hillside while driving by, uh, while they have cut during the cutting of slope, to retain the soil above, they would have constructed some of the structures to retain them. So that is for the soils. It is one of the example. And by the soils are the constructions or structures that are made using soils as the construction material itself. For example, earthen dams, uh, or embankments for railway tracks or roads or airports, runways, etc. So in this, the soil itself is used as a construction material. So to covering all the aspects, it is essential to understand the mechanics of soil, that is how soil behaves, and how the properties of soils, that is soil mechanics, can be applied for these structures, which essentially gets covered in the subsequent courses, uh, which are usually named as foundation engineering. So what is soil mechanics? So soil mechanics is a study about soils, soil mass, which comprises of both solid particles as well as fluid. So essentially, it is a coupling of solid and fluid mechanics. So in the due course of time, with the passage of the course, you will be realizing that uh, the how solid and fluid mechanics are blended with each other and how it is applied for the material called soil. So to understand this, you have to understand the properties of the soils, which are broadly classified into two. First one is index properties, which is essentially used to classify the material. And based on the classifications, how it will behave to the external loads or external stimuli is its engineering properties. Uh, Index properties, for example, it would be particle size, uh, uh, texture, shape of the particle, etc. And engineering properties would be settlement behavior, shear strength, uh, permeability, uh, that is hydraulic conductivity, and similar properties which we will be studying in the subsequent weeks. So in the first week, essentially has been covered is to understand these, you have to understand the formations of soils, how regarding what processes they have undergone, how they get formed from the parent materials, that is rocks, and what are all the different agents that are aiding in the formations of soil, and what are all the various uh, governing factor or influencing factors or driving factors, can be said, in the formations of in the soil formation is essential. So you would have seen the process of formation followed by the types of processes, what process, and that process consists of what types, and these types of processes are governed by what agents. So essentially that is being covered systematically in this week. And to give a brief idea on the book suggestions, as you know that in the week one lecture, professor has suggested a lot of books. So here, as it is a one-to-one problem solving session, uh, I thought it would be good to share my experience with uh, regarding the books and the understanding I got, with a little understanding I got with this in in this in this due course of time. So, as the standard book which has been prescribed in the course and will be followed in the course is RF Craig. And for a very basic initial understanding, I would prefer Gopal Ranjan and ASR Rao. And after, when you are familiar with these two books, you can go through Soil Mechanics by Lambe and Whitman. And finally, Mitchell and Soga. Essentially, Mitchell and Soga gives a very good understanding on the microstructural behavior of the soil and to understand what is soil. And Lambe Whitman is usually termed as Bible of soil mechanics. So, with this as background, uh, we will try to solve uh, some of the uh, questions associated with these aspects, which has been covered in week one, as well as some of the aspects, broader aspects of soil mechanics, where it is applicable and its properties. So let us move to the next slide. So question one, I would recommend you to write these questions down, since these questions will be helpful in solving the uh, current assignments, as well as it will be helpful for your final examinations. So I would suggest to please note down the questions, and If you have any doubts, you can ask in between, and discussions would be encouraged much. So, question one, geotechnical engineering deals with the changes that occur in option A, atmosphere, option B, geosphere, option C, troposphere, and option D, thermosphere. So, let me repeat the question. Geotechnical engineering deals with the changes that occur in option A, atmosphere, option B, geosphere, option C, troposphere, option D, thermosphere. So, as you can see, uh, atmosphere, troposphere, and thermosphere, these are essentially the aspects that are present, I would say, above the ground, in which the materials of the earth does not come into picture. So as far as geosphere is concerned, it consists of rocks, soils, deep underground formations, biota, uh, it is plants, animals, microbes, which essentially governs the uh, properties of soils and which determines the how the soil will behave. So, with this in view, uh, the correct answer for this question will be geosphere. Hope I am clear now. So, essentially, geosphere contains soils, rocks, organic matter, or biota, uh, groundwater, etc. Essentially, these are the main components. Uh, and all these properties comes under geosphere, and essentially all these properties affect this. Hence, geotechnical engineering needs to understand the effects of various um, external phenomena on soil properties. So moving on to the next question. Question 2. Indicate which of the following situations in real life would be falling the preview of geotechnical engineering. Let's review of geotechnical engineering. Option A, laying of foundations. Option B, understanding the underground water flow paths. Option C, to understand the suitability of soils for desired applications. And option D, all of the above. I will repeat the question once again. Indicate which of the following situations in real life would be falling in the preview of geotechnical engineering. Option A, laying of foundations. Option B, understanding the underground water flow paths. Option C, to understand the suitability of soils for desired applications. And option D, all of the above. So coming to the first options, a laying of foundations, uh, geotechnical preview of geotechnical engineering. Obviously, laying of foundations is the primary purpose, one of the primary purpose of studying soil mechanics, and that is geotechnical engineering. Because as you know, to the laying of foundations for the buildings is of utmost importance, and laying of suitable foundations and reliable foundations, I would say, which requires a deep understanding of the behavior of soil beneath, for which a certain substantial part of the budget of the projects has is being utilized to for soil exploration and the understanding of the subsurface. So obviously, laying a foundation comes into picture. Understanding the underground water flow paths. So even though a part of this falls into the aspect of hydrogeology, uh, this understanding of flow paths is particularly essential uh, to understand the seepage or to understand the permeability aspects of soil, uh, which essentially governs the uh, how we can say integrity of dams, uh, efficiency to hold water, efficiency of the reservoir, etc. And if you go to deep underground formations, uh, for example, pumping water from the aquifers, drinking water, etc. So for that, this understanding is essentially it is essential and imperative. So coming to the third option, to understand the suitability of soils for desired applications. So apart from this laying of foundations and uh, hydraulic aspects, for other aspects and for other interdisciplinary applications, soils are preferred. For example, agriculture and as a um, as a cosmetic product, etc. Soils are preferred. So for these aspects also, it is essential to understand some of the properties of the soils, which in turn fall under the purview of geotechnical engineering. So this is also a right option. Hence, obviously, since these three fall in the preview, the answer is all the above. So let us move to the third question. The domains other than civil engineering where properties of soils are studied are option A, agriculture, option B, pharmaceuticals, option C, cosmetics, all of the options mentioned. Let me repeat the question. The domains other than civil engineering where properties of soils are studied are agriculture, pharmaceuticals, cosmetics, all of the options mentioned. As we discussed earlier, agricultural aspects involve mineralogy. It is essential to understand the mineralogy. uh, water retaining capacity, organic matter, that is essentially indirectly nutrition. Etc. So these three are some of the major aspects which uh, the properties of soils are required uh, in agriculture and pharmaceuticals. Essentially, we have some of the fine materials which are highly absorbing. Examples are zeolites. Not exactly zeolites means uh, very fine powders, and their property essentially the property of soil involved is specific surface area and grain size, absorption capacity, and similarly in cosmetics also major aspect is SSA. One of the very common examples that we can find in the day-to-day life where uh, uh, actually soils are itself used as a cosmetic materials or talcum powder and famous multani mitti. So where these are finely ground materials uh, and which are these finely ground materials have more absorption capacity and they can absorb the impurities that is present in the body. Hence, they are preferred as cosmetics. Hence, all the three options utilize the properties of soils. Hence, the correct option would be all of the options mentioned. So, let us move to the next question. Which of the following aspects or activities require transportation of huge amounts of soils by human beings? Option A, formation of artificial islands. Option B, development of infrastructure, both in. Which of the following, let me repeat the question again. Which of the following activities require transportation of huge amounts of soils by human beings? Option A, formation of artificial islands. Option B, development of infrastructure. Option C, both A and B. So regarding option A is concerned, formation of artificial islands obviously requires a lot of tons and tons of soils to be brought from other places in order to create land by reclaiming a part of the ocean or sea. So one of the beautiful examples where one of the largest cities of the world has been built on this reclaimed land is Mumbai, and many and very famous palm islands are one of or some of the examples of artificial islands. and many creation of artificial islands are going on across the country and the world, which is requiring enormous amounts of soils to be transported from one part to another. And development of infrastructure. Coming to development of infrastructure, obviously formation of artificial islands is also development of infrastructure. But apart from that, we have we have the requirement for fine aggregates, uh, which is uh, a relatively very common phenomena for not phenom very common consumable in day-to-day life for the uh, preparation of concrete. And apart from those, as a backfilling material, uh, as a mm, as a embankment material, as a uh, as a or an agricultural material, etc. So these aspects require huge amounts transportation of huge amounts of soils by human beings. Hence, both of the options come into the preview of this. Hence, the right option would be both A and B. Hope I am clear. If you have any questions, you can ask, or you can also post your questions in the discussion forum that is present in the NPTEL interface, which you can access, and uh, course teaching assistants, including me, will try to answer those questions as early as possible. And I would like to inform this. And moving on to the next question. The process that leads to the formation of soils from the parent rocks. Option A, weathering. Option B, withering. Option C, transportation. And option D, none of the above. So, as we know, the entire process of formations of soils from parent rocks can be divided into, not divided, can be brought under a single umbrella of the process of weathering, which includes other, for example, transportation is a after effect of weathering, and similarly withering also. So hence weathering is the broader process. As far as this question is concerned, will be considering the broader aspect of the process of formations of soil, which is weathering. Question 6. What types of stresses lead to weathering of rocks? Option A, physical. Option B, chemical. Option C, thermal. Option D, all of the above. Let me repeat the question. What type of stresses lead to weathering of rocks? Option A, physical. Option B, chemical. Option C, thermal. And option D, all of the above. So for this, I would like to give some more insights regarding the various aspects of weathering, how it is classified, and what are the some of the governing or what are all the types of processes that uh, falls under the weathering, and how those processes have been classified into. So essentially, we know that rocks are formed or converted to soils using by the process of weathering. So this weathering can be of three types, which is physical, chemical, and biological. So these are all the three broader classifications of the types of weathering: physical, chemical, and biological. So now some of the processes that form that come under physical uh, weathering are exfoliation. Uh, Here I would like to mention that it will be useful to note this down as it is um, it is one of the aiding contribution for to the lectures or supplementary content to the lecture, which you will be which gives some more some more insight to how weathering occurs and how each parameters affect lead to weathering. So first one is exfoliation under physical weathering. Second one is thermal expansion. Third one is abrasion due to wind and water. Fourth is attrition. Fifth is frost action. So coming to exfoliation now to understand exfoliation, you need uh, let us take a block of rock that has been that is present for a long period of time. So now, due to some aspects, due to various agents like wind, water, or for example, by let us say erosion. So let us consider this point. The stresses acting at this point is due to the overburden that is present here. Let us write OB, overburden. So when this layer, I would say, let us mark by A, is getting eroded and it results in a layer where that A dash after some time where the portion A dash has been completely eroded or completely removed from the from its position. Hence now the stresses acting will be, let us say it is overburden 1 and this is overburden 2. So OB1 will be greater than OB2, which results in the reduction of stresses and which causes a stress relaxation. And due to this reduction in stresses, there will be further developments of cracks in the considered point. This process is known as exfoliation, and these cracks would subsequently uh, enhance due to further removal or various other factors, which would eventually result in disintegration of the parent rocks. So this is exfoliation. And thermal expansion. Now let us consider the same rocks, rock mass. This is exposed to the surface. Now, as we know this, there is a huge temperature difference in some of the parts of the world. There is a huge temperature difference between day and night. So during the day, the rocks that are exposed to the at the surface that are exposed to the sun or exposed outside will get heated up, and while the beneath the rock there will be the rock will not get heated up. The heat would not have been propagating to that depth. So for example, if we consider up to a depth this uh, d, there is an influence of heat. The rock here would try to expand in both the direction due to heat, even though there it depends on the coefficient of linear expansion. It will try to expand, whereas the portion below, let us consider this as A and this as B. Portion below, since there is not much difference in temperature or due to the temperature difference, uh, it will not be expanding that much. So this results in the unequal thermal stresses. It is those who are from civil and mechanical engineering background, they would have solved in solid mechanics. It is a wonderful problem of solid mechanics, where the generation of thermal stresses in a composite matter kind of thing. So this results in thermal stresses, which eventually leads to failure and subsequent disintegration of rocks. So this is the aspect of thermal expansion. And abrasion due to wind and water. Uh, abrasion is essentially a rough interaction between two particles. If these two particles are suspended in wind, it is known as wind abrasion. And if it is suspended in water, it is known as water abrasion. It falls under water abrasion. So abrasion is essentially interaction, that is rough interaction between two particles that are suspended in either wind or in water, between two suspended particles. Whereas attrition is the interaction of the one particle with another surface, completely another surface, which is not suspended. For example, if you consider a water body, moving water body, and further ground, there will be particles suspended in it. So when these particles interact between themselves, it is known as abrasion. And when these particles interact with this ground, which results in further erosion, this is known as attrition. Now coming to the frost action, we know that rocks, some of the, even though some rocks contains pores, parent rocks, and pores are usually filled with water. Mm, Usually in the permafrost conditions or during extreme winters, water in the pores freezes. So when this water freezes, as we all know, it expands. That is, the volume of ice is greater than volume of water. Hence, due to this expansion and during the increase in temperature phase, there will be thawing. So hence this cyclic expansion and contraction of pores uh, due to the formation, due to freezing and thawing of water results in uh, enhancement of cracks, which further leads to the disintegration of rocks, which forms the, which is a aspect of, which is a which falls under the action of weathering, as responsible for the formation of soils. Now coming to the chemical weathering, first is hydration, second is hydrolysis, third is carbonation, fourth one is oxidation, fifth one is desilication. Now hydration and hydrolysis, as the name suggests, it involves water. But there is a uh, significant difference between hydration and hydrolysis process. In hydration, hydration involves direct addition of H2O. Uh, for example, uh, formation of uh, plaster of Paris or gypsum from calcium sulfate is a uh, is an example of hydration. Whereas in hydrolysis, water dissociates into H plus and OH minus ions. So and reacts with uh, and reacts further. For example, formation of carbonic acid, etc. And third one is carbonation, which is essentially formation of carbonates in the action of CO2. For example, when H2CO3 reacts with calcium present in the rocks, it results in the formation of calcium carbonate. Calcium carbonate minerals, and this is one of the examples. And oxidation is essentially addition of oxygen, which the one of the best examples will be decomposition of organic matter. uh, which results in the uh, uh, which will be also falling under biological aspects, and hence these two are related to each other. Oxidation usually is also known as, in case of biological aspects, it is known as decomposition. And desilication is removal of silicate ion. Uh, so moving on to biological aspects, decomposition of organic matter, which, as I said before, it is associated with oxidation. And second aspect is microbially induced calcite precipitation, which is MICP. MICP is one of the emerging research, or emerging, not emerging, it is one of the hot research topics in the field of, in one of the, I would say, sub specialization of geotechnical engineering known as environmental geotechniques, where the action of bacteria, uh, the excretion of bacteria in the soil generates calcium carbonates or carbonates, which acts as cements between two soil grains and enhances its strength, basically. So this is MICP results in formations of uh, carbonates, which holds the, that is indirectly a soil grain also is getting created. Calcite is essentially carbonate, calcium carbonate. Hence, this is also a part of uh, weathering. So, as we know, physical weathering, we have seen the classifications, and chemical weathering also we have seen the classifications, and thermal, which is in turn associated with physical. These are the various stresses leading to weathering of rocks. Hence, the option is all the above. Now let us move to question 7. Soil that remain at the place of formation are defined as soil. Let me repeat the question. Soils that remain at the place of formation are defined as option A, transported soils, option B, residual soils, option C, none of the above. So coming to this, the weathered product from the rock can be classified into two, which is transported and residual. So what determines whether the soil is transported or residual is essentially its fate once the weathering has occurred, or once the rock has disintegrated. So the disintegrated fragments, when they remain at the place of formations or beside the uh, or or they are subjected to the similar environmental conditions as the parent rock, they are known as residual soils. And the soils which are formed at one place and they are transported by various agents and gets deposited in another place or different environment or subjected to different environmental conditions, uh, which might result in the entire nature of the soil itself are known as transported soils. So with this discussion, you might have known the answer that soil that remains in the place of formation is defined as residual soils. So in the further week, we will be studying various types of residual soils, where the various deposits of residual soils, and what is the primary, how residual and transported soils are getting differentiated based on their density, mineralogy, grain arrangement, etc. I hope you understand the discussions. So this the residual soils. I hope you are noting down the questions. Next question. Which of the following is not a transporting agency for the soils? Which of the following is not a transporting agency for the soils? Let me repeat once again. Which of the following is not a transporting agency for the soils? Option A, water. Option B, wind. Option C, gravity. Option D, microbes. Option A, water. Option B, wind. Option C, gravity. Option D, microbes. Now, as we know, uh, it is obvious that water and wind will be are obviously a transporting agent, and even gravity, for example, product if suddenly a landslide occurs or due to the natural slopes, uh, part of a very minimal part of the soil gets transported or gets rearranged, or uh, rearrangement is not a right terminology. It is getting transported. Uh, so each transporting agency and the soils resulting undergoing or being transported from by these agencies have different properties, and based on which it behaves to the external loading. So to understand the external loading, you need to understand the type of soil, and the type of soil can be translated to the nature of deposition or nature of formations. What is their uh, previous sojourn to the present, uh, to the present. So here, but among the four, microbes usually they don't uh, transport the soils. They tend to break down at their location, and hence, but they might alter the uh, uh, properties of the soils uh, comparing to that of rocks, that is their parent material. Hence, microbes are a agency of weathering, but they are not a transporting agency. Hence, the option is microbes. So moving to the next question. Question 9. Which of the following soils are predominant in delta and plain areas? Which of the following soils are predominant in delta and plain areas? Option A, residual. Option B, transported. So, as far as this question is concerned, delta and plains are essentially formed due to the soil deposits that are being brought by the river. And delta is the land between two rivers, that is surrounded by two rivers, which forms in the shape of a triangle. Uh, and plains are where the velocity of the river decreases due and its width increases. Hence, there will be a uh, deposition of soils or the broken down rocks carried by them from their point of origin at these positions due to their lesser velocity get settled. Uh, that is the suspended soil grains get settled, forming the uh, plain areas, and these deposits are known as alluvial deposits. And hence, it is obvious that they fall in the category of transported soils. Coming to question 10, which of the following types of soils fall under the category of ultrafine particles? Which of the following types of soils, repeating the question, which of the following types of soils fall under the category of ultrafine particles? Option A, sands. Option B, clays. Option C, gravel. Option D, boulder. So essentially, as far as the soils are concerned, sands, as per the standard classifications, which you will be studying further, but I would like to give a brief idea about here, since it is the relevant to the context. So sands usually are around the size to from 75 microns to 4.75 millimeters. Gravels will be greater than 4.75 millimeters. Boulders will be approximately 200 to 250 millimeters, and clays are usually less than 2 micrometers. It is 2 microns. Hence, this boulder will be this much, gravel this much, sand this much, clay. Hence, obviously, the ultrafine particles are clays. Moving to the next question. What distinct properties of soils differentiate them from other civil engineering materials? What distinct properties of soils differentiate them from other civil engineering materials? Option A, size. Option B, strength. Option C, memory. Option D, shape. So the this question mostly it will answer why soil mechanics is different and why studying it is more challenging than other as branches of civil engineering. Most of the civil engineering materials which we use for construction purposes are artificially made. That is, they are man-made and their specifications are relatively fixed earlier, and then for that specifications and standards, the materials are getting manufactured. Hence, we know how the material will behave with substantial amount of certainty. But among the construction and civil engineering materials, one of the most uncertain material will be soils. So along with it, the behavior of soil to the external load is a result of what the soil has gone through in its earlier stages, what stresses it has taken before, or what type of uh, uh, weathering process it has undergone, what type of mineralogical alterations it has undergone. The entire history that the soil has experienced is inbuilt or is embedded uh, in the soils, which we can understand by their response to the external loads. Size, for example, if you take concrete, also there are size of the grains or size of the aggregates which we use. Soils also possess size. Strength, for example, we use For example, steel, there is a tensile strength, compressive strength, concrete compressive strength. Soil also, it has uh, soil is fails by shear. So any aspect of strength is there. Shape, obviously we know there are standards. For example, in concrete, what type of aggregate should be used and what type of aggregate should be preferred for what type of purposes, etc. But as far as memory is concerned, although some of the alloys are remember their shape, they are known as shape memory alloys. Memory of the engineering behavior, memory concerned with engineering behavior or the process it has undergone, that is essentially displayed by soils, and no other natural material or no other material in among the civil engineering uh, uh, materials display this kind of property. Hence, it is memory. Hence, one more aspect is that usually many very renowned professors and renowned professionals of who practice soil mechanics and uh, who possess a deeper understanding of the behavior of soils often relate soils to human behavior. So, going to the further question, which of the following is not an engineering property of the soils? Which of the following is not an engineering property of the soils? Option A, strength. Option B, permeability. Option C, particle size. Option D, consolidation. Let me repeat the question. Which of the following is not an engineering property of soil? Option A, strength. Option B, permeability. Option C, particle size. And option D, consolidation. Now, in the earlier part of this session, uh, we have seen that the properties of soils are divided into two: index properties and engineering properties. Index properties are essentially used for classifications. Engineering properties are essentially used for understanding the behavior of soil to external loads. And it's important to note that these index properties influence to an extent the engineering properties of the soils. Hence, if you see the given options, strength is obviously an engineering property since it is one of the very commonly considered phenomena for not phenomena for parameter for the design. And consolidation is usually the settlement characteristics undergone by some type of soils. Permeability is the ability for water to flow, for water or any fluid to flow, ease of fluid flow. Which is further an engineering property of the soil. And the remaining option is particle size. So as far as particle size is concerned, particle size governs the amount of voids that will be present in the soil, and that amount of voids will further govern the permeability, and it governs the density, which will be studying further, which is defined by gamma, or as per the present notation, rho density. And based on the voids, how much settlements can take place, consolidation, and density will indirectly affect the strength. Hence, as you can see, particle size is an index property which is used to classify the soils, and this particle size in turn affects the engineering property of the soils, that is strength, permeability, and consolidation. So the purpose of giving these question is to give a brief idea of how uh, the index and engineering properties complement each other. So moving to the next question, I hope some of the uh, important aspects is being revised in this week, in this session. Uh, and it will be helpful in solving the assignments and subsequently the examination. So, what type of process is arsenic oozing out of soils? Option A, physical. Option B, chemical. Option C, thermal. Option D, biological. What type of process is arsenic oozing out of soils? Option A, physical. Option B, chemical. Option C, thermal. Option D, biological. So now arsenic oozing out of the soil is essentially not not confined to arsenic. Any chemical compound or any compound tends to uh, ooze out, or uh, tends to flow through, or tends to carry the various uh, toxic elements along with it, which might be present in soils due to natural or artificial uh, processes. So essentially, this type of uh, carrying of salts or heavy metals out of soils, the process is termed, the more technical term will be leaching. So it is just for your information. However, this course does not cover these aspects. So essentially, this arsenic oozing out of soil is essentially a chemical process. Now we are entering into some of the true or false questions, uh, which is the which marks the end of the session. Uh, but with these two questions, I have tried to generate some discussions which will be helpful for you for the further weeks, going into the further weeks and its contents respectively. So there are three questions. Microbial processes in the soils leads to both deterioration and upgradation of soils. Microbial processes in the soils leads to both deterioration and upgradation of soils. Here it is to be noted that the deterioration and upgradation of soil is terms of strength. Now these microbial processes, as we saw earlier, essentially involves decomposition and one of the aspects would be calcite precipitation. So decomposition involves breaking down of organic matter, which might lead to change in the volume occupied and may cause collapse of soils. Which fall under deterioration. MICP, on the other hand, the calcite precipitated between these rocks, soil grains, will try to enhance the strength by increasing their cohesive properties, which we'll be studying further. Is a perfect example of upgradation. So, microbial processes in the soil leads to both deterioration and upgradation of soils. It's a true statement. Now B. Acid rains might be responsible for weathering. Acid rains might be responsible for weathering. It is obvious that it is leads to acidification of water, which might cause some changes in the soil minerals, or further they might cause disintegration of which might react with rock minerals and subsequent disintegration. Hence, it is also true. So, continuing with the true or false, rocks can be formed from soils. So, rocks can be formed from soils. It should be noted that in the earlier discussions or earlier part of the lectures, we saw that soils are formed from rocks. But can rocks be formed from soils? Whether this statement holds true, to understand this, we have to understand the rock cycle. So initially from magma, we know that from deep inside the earth, the cooling of magma results in igneous rocks. So let us come. Right now, we need not go what igneous rocks means, and which and igneous rocks. We know how it is formed, and at the end, I will give some of the examples of uh, day to examples of various these types of rocks which uh, can be seen in day-to-day life. So these igneous rocks, as we see here, as we discussed earlier, due to weathering and erosion, they form sediments. That is, their ultimate product is soils. And when these igneous rocks are again subjected to heat, high temperature and pressure, they form metamorphic rocks. That is, this process is known as metamorphosis. Metamorphosis. This the action of extreme heat and pressure. So these metamorphic rocks further they undergo the same weathering and erosion due to various agents and various processes as we saw early. That is physical, chemical, biological, and erosion by various transportation agents or like wind, water, gravity, etc. They tend to form again sediments. During the process of weathering and erosion, their sizes gets reduced, they get disintegrated from the parent rocks and form loose uh, uh, sediments, loose deposits of sediment. And these sediments, in some cases, the continuous deposition of sediments for over a very long period of time gets subjected to compaction and cementation due to various pore fluid properties and due to the external loads due to the overburden deposition, and they lead to form sedimentary rocks. So here is the aspect which was asked in the question whether rocks can be formed from soils. So this aspect answers our question that rocks can be formed from soils, and further these sedimentary rocks further undergo heat and pressure, undergo metamorphosis, forming metamorphic rock, and this cycle may continue. And now, further, these sedimentary rocks, due to various other processes, they might further undergo weathering and erosion, may in turn result in sediments. This is also possible. So now, but due to high heats, these rocks, when they melt, they in turn result in magma. Some of the best examples of igneous rocks are granite and basalt. Granite, almost in all cooking platforms, granites are used, and basalts are commonly found in the Deccan Plateau of Indian region, which we'll be discussing shortly. And sedimentary rocks are sandstones and limestone. Some of the major day-to-day or common notion of using sedimentary rocks is that they are the reservoirs. That is, they are the reserves of crude oil and natural gas. So incidentally, my research work is also on these sedimentary rocks, the geomechanics of these sedimentary rocks, due to various processes. So these sedimentary rocks, sandstones and limestones. Sandstones is usually made up of quartz, and limestone is usually made up of calcite, that is calcium carbonate. These are sediments. When the quartz, that is when sand get deposited over a period of time, due to this compaction and cementation, cements usually might be carbonate or silicate. They form sandstone, limestone. Other is another as this is mudstone. Etc. Some of the sedimentary deposits. So metamorphic rocks are marble and gneiss. Marble is a common flooring material, and gneiss is used for many other purposes. So with this idea, further extending these ideas, some of the more basic uh, understanding, the rock itself consists of the definition of rock itself is an aggregate of minerals. It is an aggregate of minerals. So the minerals that make up the rocks can be classified into three types, which is siliceous, which essentially contains silica. It is SiO2. They are dominant. Common example is quartz and feldspar. Carbonaceous, where it contains carbonates, limestone and uh, dolostone. Or minerals will be calcite and dolomite. Calcite is calcium carbonate. Dolomite is magnesium carbonate. It is combination of calcium and magnesium. Third one is argillaceous clay minerals, which contains, these are aluminosilicate. They contain aluminium and silicate, SiO3 means. Combination of this forms argillaceous rocks. These three are the common rock forming minerals, which further results in formation of soils, which contains almost the same mineralogy based on their nature of deposition and the weathering processes. So, with this preface and with this extended discussion, the answer for the question 14C is 2. Example, as we saw before, is sediments to sedimentary rocks. So with this, the practice questions comes to an end. So since it is more of an introductory session and introductory week, and the major aspect covered in this week was weathering. So it will be good, or it will be better to understand the process of weathering uh, and the various types of weathering by understanding visually where our nation India is one of the best examples of different types of weathering that it has undergone. Weathering of rocks it has undergone, leading to very diversified deposits of soils. So this very apt example of weathering is the whole soil deposits of India. So if we consider this is the map of India, so this part, essentially the northern part, Himalayan belt, are essentially glacial deposits, which are most of the years they are uh, covered by ice. And one of the major aspects is uh, gravity, which is caused due to avalanche. These soils might get transported, uh, leading to the transported deposits. And second is aeolian deposits, which is uh, terminology for wind deposited soil, wind deposits. So these are found in essentially in arid and semi-arid region. Hence, they are found in western part of the region. That is essentially in Thar Desert. Thar deserts are usually aeolian deposit. They are very loose deposits. They have the tendency to shift their places. For example, sand dunes which keep on shifting their places. So next we have the west coast deposits and east coast deposits. They are essentially very fine materials, and there is a significant difference between the west coast deposits and east coast deposits, because west coast deposits are essentially the weathered products of Deccan traps, that is volcanic rock formations, which are basaltic. And some of these aspects are found in also uh, Karnataka and parts of Tamil Nadu, in near Coimbatore, Erode, etc., which essentially are rich in black, which are commonly known as black cotton soil, which are usually very uh, fertile and used for cotton cultivation, hence commonly referred as black cotton soil. And eastern deposits are relatively inert but consist of clay minerals which are relatively inactive. And some part of Madhya Pradesh near the Aravalli ranges, not in between Aravalli, Vindhya, and Chota Nagpur plateau, we find the lowest deposits, which are also wind deposits and very fine uh, silty materials. And finally, we come to plain, that is alluvial deposits. We have vast plains and numerous rivers. Some of the rivers consists of Ganga, Kaveri, KG Krishna Godavari Delta, Brahmaputra, and part of here is Mahanadi Plains, where the Ganga Plains extend from and Punjab Plains. Here, where Punjab Plains are fed by 5 rivers like Satluj, Jhelum, Ravi, Chenab, and Indus, and Ganga Plains are combination of rivers Ganga, Yamuna, Brahmaputra, obviously Mahanadi, and here there is a Krishna and Godavari, and here is Kaveri, Kolidam, etc. So as we see, the deposits from here gets transported and form a very transported deposits of alluvial soils, as these rivers originate from the Himalayas, and similarly the rivers originating from Western Ghats, they deposit the uh, western coastal deposits, and the Eastern Ghats deposit the eastern coastal deposits due to the various weathering and wind. The action of wind causes the aeolian deposits and lowest deposits, and one of the major parent rock is basaltic, which is an example of igneous rocks due to volcanic action, uh, due to sudden cooling of the lava from the one at the surface of the earth. So with this preview, I hope that a preliminary idea of weathering of soils has been covered, and hopefully further some more aspects of weathering and detailed discussions on classifications of soil, geological classifications of soils will be discussed in the forthcoming week, and I hope that further more discussions can be generated in this regard. So with this, we'll we'll conclude this session. Thank you for your patience and your time. Thank you.